What up, Jay?
Hey, thought I'd get back in here and make sure everything works. Get in
Yeah,
early.
real talk.
So just to review how I take over the screen, more actions, right?
Yes. The little three dots.
Yeah, and see here. Which one is it then?
Um. Oh wait. Share content, not the three dots. It's the arrows pointing up next to leave in the right corner, top right corner.
Oh, arrow pointing up. Share
Yeah.
content.
And then screen. Just press the screen.
Oh, press the screen with you on it.
It just says screen. So it says share content. So that the arrow pointing up, and then go to and then it says share content under that, and then if you go down a little bit, like towards the middle, it says screen, and then click the screen. It says if you just leave your mouse on it, it's called generic PNP monitor.
Yeah.
There you go. I can see it.
So you can see that then.
Yeah.
All right, so we just leave it right there, I guess.
Yeah. Leave it there. Don't
Oh,
let it go to sleep, and then we're good to go. I don't know how many you're gonna join. Um, Hopefully they all do, but we'll see.
all right, so we're just going through the screens. That's it, huh?
Yeah, yeah.
Yeah.
What's going on, Steve?
Oh, not much. How are you? Sorry, I was having some technical difficulties when I first got on.
No, it's all good, dude. Doing good. How about y'all with the lightning and all that shit yesterday? What did y'all have anything go down or?
No, from what I didn't hear nothing from all the guys. So as far as I can tell, everything looked like it stayed running. So it didn't get us like it usually does.
Good deal.
In
Yeah,
fact, it didn't really rain that much down here. In fact, when I was down south of Gatula yesterday morning, and heck, it was just barely drizzling. So yeah, it wasn't bad at all.
damn, dude, it rained its ass off here for like 3 hours, maybe more. I think we got like 2 inches.
I think that's what we got at the house. It was like just under 2 inches.
Oh man. Yeah, man, it's like 4 o'clock in the morning. It literally lightened like right out, like I don't know, maybe right down the street from me, and it shook my whole damn house. Woke
Oh, wow.
me, all the kids up. All the damn kids were yelling. I was like, shit. Whereabouts do you live, Steve? If you don't mind me asking.
I'm by Casterville.
Okay, cool.
Yeah, I'm just outside of Casterville by there. I don't know if you're familiar with that area, but Rio Medina.
Yeah.
Yeah, I'm kind of up going. I'm not by the lake, but I'm up that way.
Okay. Are you from Castroville originally?
No, I was actually born and raised in Raton, New Mexico.
Okay.
Then I transferred down here in 2012. And then I moved my family in 13. I came in December of 12, and then they moved in April of 13.
Okay.
We've been here since.
Nice.
Yeah, it's been a good move though. It was good for all of us. My son's doing good in school, and my wife likes it. So
Hell yeah. How old's your
that's the main
son?
thing. He's 15.
Oh, nice. So you going to Medina Valley?
Yes.
Nice. It's a good school.
Yeah, he's a sophomore this year.
Sweet. Yeah, I used to have some buddies from over there back when I was in high school because I'm from Pleasanton, so
Oh,
I
okay.
used to play them in football and all our sports and shit. So I know a couple guys from over there in that area.
It's growing like crazy now. Man, they're everywhere you look, they're building stuff. In fact, they're already talking. They're gonna have to build a new high school.
Yeah. Yeah, shit. It's like San Antonio's growing right into that area.
Yeah. Yeah, all that Petranco Ranch, and they're doing another expansion, another subdivision, another section of that that's
Yeah.
closer towards me. And then they've got there's like 300 some acres that are adjoin the subdivision that I'm in, and the developer just bought it. So they're supposed to do like 10 to 20 acre parcels on that one. So,
Oh.
but yeah, in fact, they just built a middle school, and it's already jam packed. It's already over capacity. So it's not. Well, boy,
Yeah,
I'm not seeing many people coming on here. I thought there'd be a whole lot more on here already.
Here we go.
Oh, there's a few. There's one. What's up, Malachi?
Hey, good morning, guys.
Morning, Malachi. Hey Jay, y'all get a bunch of rain up there in Houston, or did Skip go?
Well, it depends where you're at. I got about 1.5 inches at the house. Steve, when you were in,
Right.
did you work for EP there?
Yes. Yeah, I was with El Paso there.
So you were on all that dewatering, all that gas up there?
Yes.
You work on that ranch that Ted Turner owns?
Yes. Yeah, the Vermejo Park.
Yeah.
Yep.
That's nice
That's
territory up there. I did some work up there previous to 2010 or something we were trying to come up when I was with Lufkin, we're coming up with all this custody transfer stuff. You might have been one of the guys that actually run us off when it didn't work.
No, I may have been one of the operators out in the field, but I wouldn't have run you off.
I can't remember their names, but I went out with them when they were out there, on the meter run, trying to calibrate it and all that with the orifice and all that stuff.
Yeah, it was probably Kent Deer King.
Yeah, that sounds familiar.
Yep. Well, Robbie and Jay, I guess we'll give it a few more minutes to see who else. Look, we got a few more people chiming in. I know we do have a hard stop at 10. We've got another meeting at 10:30. And then we could always round back up, and if anybody has any more questions, Yuri and Ryan will probably have be more interested in a lot of the other technologies that you guys have, that we can meet on later at another time. But we can.
Yeah, for sure. It shouldn't take too long. I mean, Jay's just gonna run through our platform, and then it usually takes 30 to 45 minutes. It's not much, you know. It's really simple walkthrough. So
Okay. And well, and we've got a bunch of projects going on too, so we may have some that don't chime in.
okay,
That we decided after we scheduled the meeting, we had a few other things come up. So, but I think with what we got on, I think let's go ahead and get started.
okay,
And then we can go from there.
sounds like a plan.
Okay, could everybody see my screen?
Yes, I can see it.
Okay. All right. So what I'll do is this controller that I'm looking at is one of them I have in my lab at home. I've got a lab built there where I do all my testing, or a lot of it anyway. But it's a mock-up similar to what you guys have in the field that we've been giving you of the SMARTEN controller with the Toshiba AS3 drive. The AS3 is hooked up to this one. I'm running it without a motor, so I have to turn some things on and off to get it to run without faulting, since I don't have a motor sense and I don't have 3-phase. I'm just doing it on single phase. So, but anyway, we can run through all the screens. I think the important thing to note on this is we have a touch screen, and you can also access the controller through Wi-Fi or a cell modem or a regular radio with Xbox, which I think that's what you guys are doing, Xbox. I believe that is anyway.
Jay, I'm not sure if it's me, but you're cutting out some.
I'm pretty clear on this
my
end.
side anyway.
Yeah, it's clear for me, Steve.
What, I'm cutting out?
Okay, maybe. Yeah, and it may be where I'm at. I'm out on a location. I'm at a facility. I should have really good service here, but anyway, go ahead. Sorry.
Okay, what about the other guys? Am I cutting out for them as well?
I'm good on my end.
Yeah, I'm good also.
Okay, well then
Good also.
I'll keep going. All right, so I think the thing to know about the SMARTEN controller, it was designed to make it really easy to operate and to locate different screens. You'll note on my screen there's a bunch of tabs across the top. Labeled status, configuration, I/O, malfunctions, real-time cards, control mode, history, and something called well notes. And as you select each tab across the top, you end up with some tabs across the left-hand side. So under status, we have well status, which is the screen you see now, and VFD status if you're connected up to a Toshiba drive. So you'll see a lot of zeros on this status now because my drive isn't loaded or anything like that. So we'll go back up to well status. Some of the information, we've got a lot of eye candy on here in terms of showing a downhole card on its side, which is actually how the pump works. That this is upstroke, this is downstroke. 3 dials that are configurable with whatever information you want on there. 4 more sort of dials here. These aren't configurable, but it's just some general things we picked, and then some other information on below it. You can stop the drive from here. I press stop. We'll go into operator stop. Start. It gives you a little flag on the right-hand side at the top. Right-hand corner tells you what's going on. As we come up and calibrate, then our cards will go to something normal. And don't pay attention to the shape of the card. This is off of a simulator, and just some estimated rods and things like that. So the next tab, the configuration, and this is where most of the programming is done. Not all of it, but most of it. So the first tab on the left is well configuration. This is where you name your well, the company. There's a start delay, a run detect timeout, which means whatever time is plugged into this particular parameter it will allow the well to run that long without seeing any good load and position data before it will fault. And then the value of the load cell. Below that, we have the tapers and tubing, and it's easy to add or subtract here. So I can go in and pick up another, like a sinker bar, 1 inch, 100 foot, and click save. So it's that simple to add another group of rods. If I want to get rid of it, click on it again, click the X, hit save, and it's gone. At the bottom is your tubing OD, tubing anchor, how much is unanchored, so forth. On the right-hand side is our surface equipment. Everything's a drop-down box, so we can go down and pick whatever type of pumping unit it is. Back here. And then another drop-down box for the size, whether it's clockwise or counterclockwise, which crank hole you're in, the measured stroke length, structural imbalance, the type of motor you have on the unit, and the horsepower. Then the bottom right-hand corner is reserved for your fluid properties. Now, this is stuff that you guys would have to know. You know, you have to estimate what kind of leakage you have on your pump, or what the proficiency of the pump is, what the water cut is, your water density, gas density, and so on and so forth. So this helps to calculate the inferred production and the inferred pump intake pressure. But
Hey, Jay, on that, if before we know that, is there like a dummy number we can use in there to, like, as we're setting a new one up?
Yeah,
say we got a new well on.
The numbers
you have
that
like
you see in there right now are like the default numbers.
okay.
So you start off with that and then adjust it as you figure it out. I mean, that only affects your calculated inferred production and your pump intake pressure. It doesn't affect the dynamometer card or controlling the well or anything like that. So if those are incorrect, all that means is your inferred production and your inferred pump intake pressure are going to be well off.
Okay.
All right, the next tab on the left-hand side is programming the variable speed drive, which is, you know, you got to understand what some of this stuff means, but the top row, it pretty much comes from the motor nameplate, the horsepower, the rated current, and your full load speed. You know, whether or not you have a standard duty or inverter duty motor. You go back here and stop. I won't be able to get some of these while it's running. Okay, for the auto tuning, there's a drop down box. So you guys, if I remember correctly from when I've been out there, you are using the big silver box on top of the unit, so you are using a dynamic braking resistor. So the one you would select would be the one that says DBR, which is short for dynamic braking, and the type of auto tuning that's going to be done. Click that, hit save. So what that means, it's going to do a motor auto tune and then an auto tune right before it starts up, and that gives you a better control of your output frequency. If you don't have the DBR, then you would select no DBR overspeed, and what that does, it deals with the regeneration from the unbalanced load by speeding up the unit rather than putting that energy on that silver box. For the time being, let's just say DVR. There's a lot more selections in this drop-down box, as you can see. So don't get confused. You really only got to bounce back and forth between overspeed and DVR, depending on what you use. We added the rest of these for you always, let me put it this way, we always run into somebody that wants to do something a little bit different than the norm. So instead of having to go directly into the VFD to make the change, we just put them all in the drop down box. So the selection's there should they ever want to do that. But the two normal ones are the no DVR overspeed and the DVR 4 + 2 = 0. We use the exact same nomenclature that's used in the Toshiba manual, if you're wondering why some of these look kind of weird. Okay, then we have minimum frequency and maximum frequency. We try to set those from 0 to 100. So that kind of gives you, that's the operating range that you can work within. That doesn't mean that's what it's going to run up to 100 hertz. It just gives you that window that you can operate within when you set it up on your minimum startup speed, min speed, low speed, peak speed, and all that, which we'll get to in a little while. So we try to do that at 0 to 100. Carrier frequency set to a 4. I don't know if any of you guys have been around drives or not, but when they're running, you can kind of hear a high-pitched noise coming from the motor. That's the carrier frequency. The higher you make that number, the quieter the motor gets, but it begins to run a little bit hotter. So we try to pick a number it's not too loud, but yet the motor will still run cool, which is about 4 kilohertz. If you have hearing like I do, I don't even hear the 4 kilohertz. So next is acceleration and deceleration time, and that's the amount of time it takes to go from a starting stop to whatever our max operating frequency is. So it really doesn't affect you guys a lot unless you were to use say a linear unit where you're going to do some cornering features like slow down around the top, slow down around the bottom. You would probably have to drop the accel and decel times to accomplish that slowdown and speed up. But for normal pumping units, 10 seconds fine. Base frequency, that again comes off your motor nameplate. So in my case, my drive is a 240 volt drive that I have on my workbench. You guys will have 480. So you will look on your motor nameplate, and if it says 460, if it says 480, whatever it may happen to say on the motor nameplate. Base frequency, everything you got is going to be 60 hertz, just regular line frequency. I mean, we do have an option when we go on the international side to change to 50 hertz. Everything you'll ever see is 60. Okay, gearbox torque reading, that's taken from the numbers on this side. So, your gearbox is 56. So here we would actually put in 56. And what that provides, if you overload your gearbox, the torque limiting will kick in and begin to slow it down to bring it back below what the gearbox rating is. It's just a protective feature. We actually are looking at motor torque, and then there's a calculation we go through to get to gearbox torque. So however you set that, that will prevent it from overloading the unit, gearbox-wise. All right, we have a VFD pattern, and again, it's sort of like the auto tuning. You select overspeed up here, we'll select overspeed here. The other selection is normal DVR vector out. So if we turn that on and save it, it's going to enable the dynamic braking information. So all of this, you'll want to set up the protection for we'll enable it to oil trip. And what that does, it's a calculation that the VFD makes to prevent the energy from going up to the DVR, prevent it from overloading it, getting too hot and so forth. We have two protections on the DVR. We have the calculated overload value in kW, and we also have a thermal switch in the DVR. If it gets too hot, it'll open a circuit and shut the well down. So when you're using that silver box, there should be a nameplate on the side of it that has braking resistance and braking capacity in kW. So get those values, plug it in here. That's what's going to be used to calculate this overload trip. Okay, the under voltage limit, or over voltage limit rather, all that is that's the determination that the VFD makes when my bus voltage gets above a certain value, that it dumps all the excess voltage to the dynamic brake. So this is in percent of its rating. 120% would be equal to like 480 volts on the input. So this can get up to like 500 something on the bus, and then it dumps all the excess to the silver box on top. The next two, input phase loss detection and output phase loss detection. Input phase loss detection is, if you lose a line fuse. If that's enabled, then you should get a trip. The thing to remember about it, even though they say it's input phase loss, is not truly how it's being detected. It's looking at the DC bus in the inverter, because the incoming line voltage has changed to DC voltage like a battery. But when you have three phases, it's converting each one of those, and you end up with a little bit of ripple on it, and then it filters it out to make it nice and smooth on the caps. So it's looking at that. When you lose a line fuse, you actually end up with a lot more ripple. So it's looking at that ripple on the bus to determine that you have an input phase loss. Now, sometimes it can get confused if you have a very unbalanced input. Say you have one of them that's 480, one of them that's 500, and one of them that's 465 on your three legs. You're probably going to get an input phase loss because you're going to have a lot of bus ripple. So in those cases, you'll have to disable it to get rid of that problem. Okay, next one is output phase loss. This is to the motor. Should we lose we lose a connection or something like that going out to the motor, and then all three phases are not reaching that point, you'll end up with a fault called output phase loss. We usually leave that one enabled, but we ship it with input phase loss disabled and output phase loss enabled. But we leave it up to the customer to decide if they want the input phase loss detection. Then the next 5 entries are your ESD shutdowns. That would be your flow line pressure switch, your vibration, your DVR over temp, environmental pot, so on and so forth. So all that means is no function means they're not working on the drive. But then we would choose, once we install them, is it a normally open contact or normally closed contact? So like a environmental switch would be normally closed, a pressure switch would be normally open. So when it changes state, then you end up with a fault. Now, if you ever look inside the drive, you'll notice that there's a bank of relays. Each relay is going to be connected to one of your ESD inputs. And each one of these relays will have 2 outputs. One that goes to these inputs on the drive, the terminal S1 through S5, and another contact that goes to your digital input on the SMARTEN controller. On the SMARTEN controller, that's where you're going to label it and call it vibration switch or whatever you might want to, how many retries you want. Is it tripped, open, or closed, or whatever? So okay, these two kind of work in conjunction with each other. The reason for that is that some customers will want to allow their units to run in hand long term. And if you didn't have these inputs to the drive and you only had them to the SMARTEN, when you put it in hand, the SMARTEN's no longer in play. It will not shut it down if you have a vibration or a high pressure or anything like that. So we also take these inputs to the drive because it doesn't care if it's in hand or auto. It'll shut down either way. We do add a small delay into these inputs of about 1,000 milliseconds or 1 second, because we want to ensure when this relay trips that the input to the digital inputs on SMARTEN, it sees that first before it sees the VFD fault, because we want to end up with that label on our well status that says vibration switch. We don't want to see VFD fault.
So Jay, on what you just said there, we can actually put a name to, like for example, on a Lufkin drive, if you have a Murphy switch trip, it may say the unit's down on logic 3.
Right.
You can actually put in there Murphy switch, or is it going to say terminal S1 func?
It's going to say Murphy switch.
Okay, so you can actually label. Okay, that's great. Thank you.
Yeah, that's why we put that delay into this terminal 1. I mean, you're going to have 2 trips that happen simultaneously. You're going to have the one to that digital input that says Murphy, and you're going to have one at the drive. But the drive will take a full second longer to happen than the one on the SMARTEN. So we should always see the SMARTEN first.
Okay, and where can we change the name of those?
Okay, it'll be on the IO section. I'll be getting to there in a second.
Okay.
Okay, so when we change this stuff, as you can see, there'll be let me just go back and change mine back. So hit save, and you'll get all this information on the right-hand side on the screen that says it was a success. Okay, at the bottom, there's also the fault handling for the VFD. How many retries we're going to allow, what the downtime is for each one, how long we let it run for normal before we reset the number of current retries that we're looking at. So, I mean, there are faults that are normal. Let's say you get a slug of gas and we get a motor overload trip. Well, with a certain amount of downtime, the motor's going to cool, it's going to reset after the downtime expires, and it's going to restart, and it may run fine from then on. What you try to do is, okay, so I don't want a single fault to cause a malfunction and prevent me from making oil. I want my controller to go back and look at it again to see if it's cleared or not. And if it's cleared, it'll go ahead and start. If it's not cleared, then it's going to stay down and increment the current retries. And once you exceed the retries allowed, then it goes into a malfunction state and will not restart on its own. It will require operator intervention. So it allows the operator to kind of pick and choose, okay, I want to allow it to fault this many times consecutively and have a downtime before I actually shut this thing down and I got to go out and look at it. I want it to look to see if it's recovered on its own.
So Jay, help me understand when you like maybe a different example of that. So you said if we get a slug of gas,
yeah,
and it goes to malfunction, are you saying it would trip? What would it trip, and how would it look?
It could happen several different ways.
Right.
You get a slug of gas, it's going to throw everything way out of balance.
Right.
All right. That means when you go out and you do that, you're going to be requiring more amperage to pick up the weights. It's going to be, when the weights are falling, it's going to be regenerating more energy. So more energy is going to be going up to the DVR. So there could be any number of, it may not trip at all, but then sometimes the case is so severe where it's too much energy and it's going to trip to protect itself.
Okay, but do you have to set up these faults, or is there ones already programmed in there?
It's already programmed.
Okay.
It's for motor, it's your standard motor overload protection, just like if you were using a cross-line starter.
Okay.
The inverter itself has a similar overload curve. the DBR has this overload factor that we just looked at a second ago. Plus, it has a thermal switch. If it gets too hot, and not allowed to cool down sufficiently, then it's going to open and trip as well. And
Okay,
again,
I got you.
it's also possible that you know, if it's severe enough, you could end up with an overcurrent trip. So, I mean, it's sort of like a little racetrack. Which one's going to get there first, and which one's it going to trip on?
Okay, and again, I'm just trying to make sure I'm comparing it and understanding. Like on the Lufkin drive, sometimes you'll see a drive fault or a malfunction. Would that be what these are looking at?
Yeah, it'd
Okay.
be the same thing.
Okay.
Except on the Lufkin, it's just going to say drive fault. You have to go into I think menu 773 to actually see what that drive fault is.
Correct. Okay.
Here, we're going to put it right up on the screen for you. If it's an overcurrent trip, it's going to say overcurrent on the status. If it's a DBR overload, it'll say that. If it's motor overload, it'll say that. You won't have to go searching anywhere for it. It'll be
Right. And on the Lufkins, it's not set up to where there's retries that are allowed, correct? It's just going to shut it down and you have to manually restart.
you know, you can have retries on the Lufkin as well.
Okay. I may want to pick your brain on that later because I'm not sure we're currently set up to do that on the ones we do have Lufkins on.
I mean, they're really similar because it's both Toshiba drives. So they do have retries, and they do have a way to go menu 216 next, something like that. It's been almost 4 years since I was over there. But you can go in and disable your input phase and output phase faults as well.
Okay. Thanks, sir.
The only thing that Lufkin doesn't have is if you do trip and you restart and it works fine, it counts up those retries over a 24-hour period, and it doesn't reset till gauge off time. Or on this one, the operator sets the time frame. So I'm going to say, well, if I start up and I run for an hour, I'm going to clear out my retries. I don't want them to keep accumulating. And if I have 3 of these trips over the next month, then all of a sudden I go to malfunction. I want to clear out that counter. Lufkin does it every night at gauge off. Okay. Next tab is system setup. And since you guys you're bringing up Lufkin, you know how you navigate the Lufkin screens. You have to kind of know the menu, you know, 2, 1, 6, 2, 1 stuff to get to certain screens. And when you first start one up, you've got this quick start you got to go through so that it kind of leads you to all the screens you need to get the well running. Except that it really doesn't, because it doesn't set up your IO or any of your ESDs. But on this one, we don't have that kind of quick start. We don't have those numbers. We just have the tabs across the top and the tabs across the left-hand side. You know, working with both of them, I think this is a lot easier. The new Lufkin unit, you know, it's kind of similar. They got that color display, but they use hot buttons instead of a touch screen. And it gets, the only thing I didn't like about it when I was helping to develop that one was you start hitting these hot buttons and you go down this little rabbit hole to find a certain parameter you want. Well, you just can't back up. You got to jump all the way out, then go back down again. And it just, you know, I didn't care for it that much. This just, to me, it's just, this is easy. So anyway, setup screen, this is where we would set our current date and time. You can set up passwords for access through the screen. There's the way you can go in and like set up a, if you have Ethernet connection anyway. So what is here? Okay, so I don't know what's going on here.
On that feature there, I've never seen that feature, but like say we've got guys that work different hitches. Is there a way that automatically swaps like at hitch time, or like say we got a malfunction peak overload or something like that goes down, or does it just go to one person?
Well, it would go to, let's say, for instance, my screen timed out. I guess that's why it wasn't looking right. So, like for this particular one, I've got this one set up to email me if there's a fault or malfunction. I can set up any of these things, like for everything, or if somebody changes a configuration, if it just goes into idle, or if there's a power fluctuation, so on and so forth. So on mine, I just choose the fault and malfunction for it to notify me.
Okay. Because we do have it.
I think if you're the answer to your question, Steve, is if whoever's on this email list right here or down for the email event types enabled right here. Oh, I guess notification. Sorry, I didn't see that. Whoever's on that, they will get the email for whatever happened. I think is that what you were asking?
Well, like no, we've got several different operators, on each of these routes. So like we do get alarms through SCADA if they're set up, on tubing and casing and certain other things. But like something like this would be, I think, beneficial for a bigger oil producing well that went down on a malfunction, for the operator to maybe get an email on it. Because sometimes they don't see that until the morning, on our SCADA report.
Yeah. You can log in right here and add your email, and then you will get a notification.
Okay.
Each operator can put their email address, and then they can customize which faults they want or how they want to be notified.
Okay.
But I mean, the trick, you got to have Ethernet connection, have that capability.
Okay. Yeah, and we got internet at all our locations out here. So.
Okay.
Okay. Cool. Thank you.
Man, this is one of the greatest things for me, because as a tech support guy and designing all this equipment and everything, trying to keep a close eye on problems and stuff, and we're looking at new firmware and so on and so forth. The customers that will allow me, that have cell modems, I set this up, and I'm probably monitoring a good 200 wells right now for different customers, and I get the notifications if there's something weird going on. So I usually know about problems before they do, which comes in handy, especially if we're running some kind of test or new firmware and stuff like that. Or if I'm looking for a trend in a certain type of problem, then I can see across a broader area almost in real time when it's happening. So it's a really good tool for me, the way I use it, and I think it would be a good tool for the operators as well. Okay, also on this screen, we can download the configuration. So if we click on that one, it's going to give us a little notification. Click turning, and I can save the configuration from this well to my download file. Later, if I want to come back and change it, I can hit upload, and it'll take me back to a file, and I pick that configuration for this well and upload it back in. I can clear all my history on this tab, or I can do a complete factory reset. The other neat thing on here is that you can load firmware from here. So if you have the firmware on your laptop, click the select firmware file, and it'll bring, I have everything, the firmware, and I could go in here and click, I've got a lot of stuff because I do a lot of testing. So I could go click the most recent one and load it back into the controller. Now the tool that I'm using, just to go back here just a little bit, get this over here. It's called a SMARTEN launcher. So this is free software that you guys can get. And you notice that on this, you can add all your wells in here. It's like a menu tree. And you can get the latest SMARTEN firmware. You can make a USB, a thumb drive for images, and do all, I mean, it's all the latest. It takes you directly to it if you got internet connection. So you can always have the latest firmware if you guys choose to do updates yourself. And I don't know if any of you have this, but Robbie can get it for you.
None of us do, but we for sure. I think Blake, Ryan, and Yuri would be beneficial. Myself.
Yeah, I mean it's a good tool. There's a com test, you know, all sorts of things you can use here, and it's very easy. I mean, you just click on it, it'll go in, download the software for you, and then once you have it on your computer, you just, if you know where you put it in what file, you can upgrade it from here.
Okay. I guess every now that I'm thinking about it more, that everybody on this that was invited to this, you know, would be, I think it would benefit everybody, but like I said, for sure, those three engineers and myself.
Yeah. Okay. Next tab is network. So here's where, since, you know, I've got a cell modem connected to mine, I've got an Ethernet, you know, IP addresses and stuff. That's here. This, we communicate to the Toshiba drive via Ethernet. So this is the IP address and subnet mask we use for that. This is the IP address for the Wi-Fi. And I mean, that's the default for all Wi-Fi. You can change it because we left this one open just in case it conflicts with something. Okay, next one is Modbus. You know, there's some stuff for SCADA here. This is your VFD stuff. This is the Toshiba AS3. So, you know, I've had 2,792,000 transactions, 4 failures. It gives me, you know, how I've got it set up, whether it's enabled or not. And we have several different VFD drivers in here. I can just go back and stop it. So right now there's 3 different drivers. We used to use Fuji Frenic a lot. We still have them in the field. We use in our product we use the Toshiba AS3, and when we're dealing with the Lufkin products, they of course have the Toshiba AS1. So if you had a Lufkin and we did a retrofit, put a SMARTEN in it, then our driver we would pick would be the AS1. We'll probably be adding more to that as time goes by. And Steve, do you guys use Hall effects for position?
Yes.
Okay. So this is the screen where we would set up the Hall effects, or at least enable it to see what our in revs are, sort of just like the Lufkin. There's a button here to calibrate them.
And so I guess I'm on the new SMARTEN controllers that you guys have been installing. We haven't been, we just been using the position sensor, but on, you know, like our Lufkins and that, yes, we are using the Hall effects.
Yeah, so if you do a retrofit, then you'd have to come up and enable your Hall effects here. There's a couple of other setups you have to do on the digital inputs to connect the crank and the RPM. And we can look at that now, since the next tab on the top is I/O. So this is all of our digital inputs, digital outputs, analog inputs, and analog outputs. So we have 10 digital ins. We have 8 analog inputs, 2 analog outputs, and 10 digital outputs. So the first 2 digital inputs are usually reserved for contacts on your HOA switch if you have a drive. So we can know, it'll tell us if it's open and closed, and that gives us the status of that. The next the next 5 rather, are connected to that S1 through S5 terminal that we saw on the VFD screen. This is the corresponding input. So this is where, if label it, start this thing. Already triggered. Change that. This would have been easier if I had it right in front of me so I could flip the switches. So I got to kind of monkey with it a little bit from here, because I'm in Houston. Oh shoot, auto tuning. Wait a second. I guess I didn't turn that off. Yeah. Okay, so let's start this thing again. Go back to IO. Okay, so what I was saying about being able to label these inputs, I have my first input labeled as ESD test number 1. It is currently closed state. My trigger state is open, but if I tell it that my trigger state is closed, I'll end up going into a fault, which you can see down here. And when I look at my status, it's going to tell me fault, digital input 3, ESD test 1. So if this was a vibration or pressure, something like that, in the parentheses, it would tell you that vibration, pressure, EnviroPot, DVR, whatnot, facility, however you choose to label them. So it does show up on the well status. But there's none of that going through and figure it out. Well, okay, this is logic expression 2. Now I got to look at this little piece of paper or whatever we used to write on the inside of the door and say logic expression 2 is a EnviroPot. Or sometimes, we may have combined them. It may say EnviroPot or vibration. So you don't know which one it is. It's just one of the two. Change this.
Where do you rename that, Jay? Was it there on that description?
Yeah,
I
right
saw
here.
when you, okay, so the name on it there? Okay, on general, okay.
So this is the name, and this is where you tell it what's a violation. The trigger state, if it opens, that's the violation. I don't have any delay in this input. I'm gonna let it retry twice with a downtime of 1 minute. I don't have a reset time in here. I mean, these are kind of like weird numbers because I use it for testing. Normally you would probably have maybe 5 retries with a 5-minute downtime and a reset time of 30 minutes or something. So if everything comes up and runs for 30 minutes without a problem, you take these current retries and change it back to 0. I mean, this is all configurable. It's all to your own taste. I mean, there's no right or wrong to this. I mean, if there was a wrong to it, I would say doing it without any retries or anything. So the very first time anything happens, it goes straight to malfunction and you quit making oil. It won't retry and take a look again. I mean, obviously, like a vibration switch, that's a latch anyway. So once it trips, it's never going to change. However, like a DVR overheat, that will clear on itself once it's allowed to cool off. So it could restart and run again. So, I mean, there's several things like that. the environmental pots, depending on which ones you use. There's some out there that are very jicky and intermittent and will cause a shutdown. And the next time you look at it, it's okay and it's ready to go. So I mean, it's kind of weird to say that. Well, if I get one of these, I just want to go into malfunction, quit making oil, when it's probably just the vibration in the ViraPod itself that caused the problem. It's not really full. If it was really full, when you tried to restart, it would sense it and go right back down, and you'd eventually go into malfunction anyway. So if the status of your shutdown doesn't change, you will eventually go to malfunction. And Steve, I think it was out there when I was with Lufkin with you guys that we found a problem with some of these EnviroPods. I don't know if you recall that, but man, we were swapping out drives and looking in the gearbox and all kinds of other things when we finally realized it was this intermittent environmental pod out there that was causing the run signal to drop in and out for a split second.
Yeah, and that's what, in fact, Robert was out here. I think he's finally the one who ended up finding it on one of them, that it was just that little vibration would trip it. Yeah. And then, so yes, I do remember that.
And that's another reason we use this 1,000 millisecond delay on the input to the drive. So we avoid that problem. If it's just a split second with that vibration, that'll trip that switch and it goes back closed again. We just kind of skip over it. So we avoid that problem with this design anyway. The Lufkin was designed differently. I mean, it actually broke a run permissive in the drive just for that split second. So it would take your drive speed all the way down to 0. And in that split second, when it closed again, then the drive speed would go all the way back up to the top, which usually caused some sort of motor overload trip or overcurrent trip. Sometimes you might even end up with a no RPM in there. I mean, that was the devil for us to find that one, but now we know about it. Okay, so we can do 5 of them that are intertwined with the drive. The digital input 8 is one we did a little bit different. We don't take that one to a drive digital input. We actually take it to the standby on the drive, so that the purpose was for a pumper or a tail switch. If you're back there trying to move the pumping unit and pull the brake, you can use this that will start the drive and stop the drive without causing a fault, so that you got to walk back over to the controller, clear the fault, go back over there and try again. With this one, you can turn it on and off from the tail and then position it where you want it and pull the brake. That's also handy, if you're doing valve checks. You can use that tail switch and the brake. If your controller's close enough, you can use the HOA switch and stuff to do it. But anyway, we left this open. We just kind of, it can be used as an ESD, but we kind of designed it to be used for this start and stop for the pumper tail switch. The last 2, digital 9 and 10, when you are using HoloFX, we program these inputs for the RPM and the crank sensor. We have the analog. This is the position or the inclinometer that we must be putting in on some of the newer stuff. So in this case, the stroke position would be enabled, and we would not program the HoloFX. So now we're running on a analog position. But that still leaves like 2, 3, 4, 5, 6, 7 analog inputs you can use, which can be labeled as well. Okay. Next tab is custom functions. Now this custom functions is similar to the logic expression on a Lufkin, except that the Lufkin, you had to use it to get any of your ESDs to work. Custom function it's more, you don't have to have this for your ESDs to work, but you might want to use it to create special circumstances, like if X and Y happen and stay there for X amount of time. Then it turns on this light. And, there's all sorts of functionality to it. We have a load and position diagram, which is sometimes helpful in troubleshooting a load or position problem. Blue one is the blue line's position. The orange one is load. And we also have valve check. So you can either do it from your laptop, start and stop the well to create a valve check. And whereas on the Lufkin, it's valve check, you had 4 minutes to do whatever valve check you're going to do, and then it just stopped and saved that information. Here, you can do as many as you want. So every time you stop the well and pull the brake on the upstroke or the downstroke, depending on which one you're checking, once it exceeds this duration time right here, then it'll take the data and enter it. It'll automatically identify whether it's a standing valve or a traveling valve check, depending on where you stopped it in the position. And then it'll put a timestamp, the duration, what speed you're running, what the load was when you began, what the load was when you end, and how much your load changed during that time frame. So you can do as many as you want right there. Once you're done, if you got a guy in the field out there doing valve checks, the engineer wants to see it, all he has to do is export the file, email it to the engineer. So I think it's a really easy way to do valve checks. It's easy to get the information. What we don't do that Lufkin claims to do is actually calculate barrels per day loss based on this information, which I can promise you from being there and testing it extensively, that calculation doesn't work. So we elected not to even try to do that in here. We're just going to tell you that we had the thing stopped in the upstroke for this long. This is how much weight you lost. So that's usually a good indication of how badly your traveling valve's leaking or your standing valve. Any questions on this one? Okay. Next one is malfunctions. And this is where we would go and set our peak and load set points, fluid load malfunction, and position faults. Set very similar to the way you do it with Lufkin. You can enable it, set the value you want it to trigger at. There's violations allowed, retries, and downtime. Now, in Lufkin, you really didn't have violations allowed for peak and minimum load set points. It was just built into firmware. If you went over your set point by a certain amount for so long, then it would trigger this violation. Here we allow that to be settable. This violations allowed for peak and min load here, that's not strokes. I kind of misconstrued that when I came to work here. I thought, man, we're going to do strokes? That doesn't make sense. But it's not strokes, it's data points. We save 200 data points on each dynamometer card, 100 in the upstroke, 100 in the downstroke. And all this is saying is that for 3 of those data points, or 3% of the time, if we're above whatever our trigger value is, then we declare a peak load. So it gives you a little bit of flexibility for, sometimes you just may have a small bump. You may not want it to shut down. You only want it to shut down if you stay above your peak load set point for X amount of time. Or you could have, let's say we use this sometimes with a very intermittent load cable where you see a spike on your load either up or down, which is just lasts 1 or 2 data points and goes away. Well, a Lufkin, that would shut you down and declare a malfunction for your peak or minimum load. It really wasn't a peak or minimum load. It was just the intermittent cable. You could, to get by that until you fix it, or you may want to live with something like that, you could put your violations allowed to maybe 10. These little spikes that happen intermittently throughout the day won't shut you down. but yet if you actually violate your peak or minimum load long term, then that shuts you down. Was that clear as mud? Just just a way to, gives the operator a little more flexibility. Some people may say, no, I mean, if I violate my peak load for one data point, 1% by any amount, could be by 10 pounds, I'm going to shut the well down and quit making oil. Sometimes I'm not sure that's what you want to do in all cases. It all depends on your operating philosophy, I guess. All we trying to do is give you some flexibility. Okay, one other tab is your Hall effects. So if you are using Hall effects, we do similar stuff that Lufkin does on the belt slip and early start of stroke. Kind of tells you if your switches are working or not. So next one is real-time card. So, I mean, this, again, it's very similar to some Lufkin screens. You look at your surface card on top, your downhole card on the bottom. Gives you some other statistics over on the right-hand side. You can adjust downstroke or upstroke friction from here. If you were to see a pump card with a hump on it, you might want to adjust your upstroke friction to make it look correct. Peak load, min load, your pump fillage, SPM, all sorts of information on the right-hand side. You can clear them from here. If I want to compare it, it's kind of got the little reference, kind of same thing that Lufkin does right here. Or I can say, okay, I just saw something right here. I want to save those last 5 cards. So it created a reference and entered it into the card library, which is in history. So I just saved those cards. So let's just jump over to history right quick. And I can see that this is my reference cards I just saved. These are 5 cards. Turn on the set point, turn off the overlay. So first card, second card, third card, fourth card, and fifth card. So now I'm looking at this and I'm saying, okay, I want to take this information and I want to export it so I can put it in some sort of diagnostic program, XDiag or whatever else you guys may be using. So you can save this card information as a CSV, JSON, or DYN file. Then use it to put into your analysis program. Okay, so let's just back up to our control mode. Okay, under the control mode, this is where we would set our operating mode. If we want to run it host, just pump fill, which is regular pump off controller, surface control, a timer, or variable speed. Those are our options. Now we're expanding those options in later firmware, but that's the 5 that exist now. So we selected host mode. We're just going to tell it what speed we want it to run. And it'll run. If we want to go timer, then we have an on time and an off time and what speed we want it to run. And then, pump fillage, pretty much the same as we're doing here. We're looking at a pump fillage set point, but it would be like for on-off control. Or surface, where we're controlling off the surface card, and we're looking at an intersection of our loaded position to determine where pump off is. There are still people out there that want to control off the surface card. And in some places, it's just fine, because if it's a shallow well, your surface card and pump card look pretty much the same. So we're in VFD. We can look at it in Hertz, or we can set it in SPM. My SPM are going to be way off because I'm using a simulator. Okay, this is our pump fillage target and our deadband, which means as long as our pump fillage is within the deadband of 75%, so deadband's 3%, so that means from 72 to 78%, the controller takes no action. It just runs. It continues to run at whatever speed it was running at when it entered into the deadband. Not until it goes above 78 does it increase speed, or go below 72 does it decrease speed. So once again, that is adjustable. Okay, we have that's like secondary pump fillage that we can turn on. So if our pump fillage hits 50% for 3 consecutive strokes, we're going to go into the downtime. Downtime expires, we start back up. And that works in conjunction with your normal speed control.
Hey, Jay, real quick.
Yep.
I'm looking at one of these on one of our Newman wells, and it doesn't have the shutdown fillage at this. I thought I'd seen it somewhere else. Is this a firmware update thing?
Yeah, you have to update the firmware.
Okay.
To at least 4.3 is what I'm running. You're probably running, you could be running 4.2 or maybe even older up there. I'm not sure how long you've had it.
4.2.1. Yeah, 4.2.1.
Okay, yeah, you'd have to get to 4.3 then.
Okay, is that shutdown fillage somewhere else though? It still has a secondary, right?
It's got your slow speed, which works much the same way. I mean, there's 2 different ways here. You can either do it based on strictly on pump fillage and number of strokes, you give it a downtime, or you can say my slow speed, whereas if I'm at my slow speed of 30 hertz for whatever this duration is, 2 minutes, then I give it a downtime. Now the slow speed's going to be in the one you have for sure.
Got it. Yeah, it is. Okay.
The shutdown fillage, the secondary fillage is something new.
Got it. Okay.
I mean, and they work together. You can use both at the same time with your speed control if you like. It's kind of complicated doing that, but some people want to do it. Say, okay, when I run at my minimum speed for X amount of time, then I give it a downtime. Others say, no, if I have some pump fillage strokes that hit a certain value, then I want to shut it down. So we just thought we'll give you both options, whatever you want to do.
Okay.
If you want to do both, that's fine too. Okay, we also have some other load mitigation stuff. We have a load limiting. So if we need enable that, we have a load limit on the minimum and a load limit on the max. What this does is whatever you have set in here, so let's say you have 5,000 in your minimum and 20,000 in your peak, just as a for instance. When you hit 20,000 pounds, what the drive is going to do is slow down by 2 hertz. If you hit it again on the next stroke, it'll slow down by 2 hertz again until you're not hitting that peak load. So if you got this load limiting set at 20,000, and let's say your peak load set point for shutdown set at 25, this could be like a little buffer to keep you from actually shutting down from exceeding that set point. All you'll end up doing, okay, well, I'll slow down a little bit to keep from doing. I may be overloading something, but it allows you to slow down. When it's no longer hitting that set point, then it begins to speed back up. Lufkin has a similar thing in it too. There's rod float mitigation. You guys, of course, wouldn't use that. That would be where there's heavy crude and you get a lot of carrier bar and load cell separation. And then there's a pump tag detect. Right now, in this firmware, this just gives you an alarm. Once you set it up, it's just going to look at the last, let's see, I think 5% of the downstroke. And if you see a load change that exceeds this value, it's going to give you an alarm that you're tagging the pump. In newer versions, you'll even have the ability to do a shutdown. Questions on those? Okay.
Yes, sir.
Tab is zones. Now, I won't go in here and set it all up, but this is mainly for your long stroke linear units where you want to slow down around the corners. You can actually set, something, let's say 15% before I get to the top of the stroke, I want to slow my speed down by X amount of hertz or by a certain percentage. When I get around the top and I'm 15% on the way down, I want to speed back up to my normal speed till I get 20% from the bottom, slow down again, go around the bottom. I get on my way back up, I speed back up. Some people call it a racetrack mode or something like that, or speed zones and whatever, but it's all entirely configurable where you want to speed it up, where you want to slow it down. Since you're used to Lufkin, they had speed zones, and they also had something called upstroke downstroke control where you could slow it down in the downstroke or speed it up in the upstroke or whatever. Well, I mean, this kind of combines both of those things. Mostly used on the linear long stroke units, but I've seen it be useful on wells where the traveling valve doesn't seat immediately on the upstroke, and then maybe 20% in the upstroke it finally seats, and you get this big old shock on the way up, and it does that on every stroke. I mean, there's ways that you can say, okay, I want to slow down during that portion, give my traveling valve time to seat, and then take off and eliminate that shock wave. I've done that on quite a few wells. I mean, some people even have a theory where, well, I'm using a pump off controller for what reason? Well, it's to control, the fluid pound or the shock wave, when my plunger contacts fluid. Okay, well, I'm running at a certain speed. Let's say something goes through the pump and I'm running at my high speed, and then all of a sudden I get this, big pound. Well, they might say, well, I'm just going to try to get around that. So I'm going to say on every stroke, 30% or 40% before I get all the way to the bottom, I'm going to slow down just in case. When I go around the bottom, then I speed back up. To compensate or get my average strokes per minute, I'll make my speed up a little bit higher because I'm slowing down toward the bottom. And I still end up with the same average strokes per minute. So, I mean, there's all kinds, again, depends on your operating philosophy. It's just a tool. There's all kinds of things you can do should you choose to do it.
Hey, Jay.
Yeah.
Can we go back to the mode setup and you kind of talk us through the peak, high, and low and slow speeds real quick?
This load mitigation?
No, on the mode setup, the tab above it.
Oh, okay, yeah, the mode set.
Yeah, the peak and the high speed, kind of what the difference between those two
Oh.
are, and low and the slow.
Okay, yeah, I kind of skipped that. I'm sorry. Startup speed is just what it means. When you start it, that's the speed it's going to come on and run at for the duration that you have plugged in. So once this time frame expires, it's going to look at your pump village and whether you're in and out of this deadband, and then decide, well, if I'm above the deadband, I'm supposed to be speeding up. So then I'm going to go from whatever my startup speed is, I'm going to go up in whatever increments I have set in these boxes. I'm going to increase by that much on each stroke until I reach my high speed of 55. I'm going to remain there for 2 minutes. And after 2 minutes, if I'm still above my deadband, then I'm going to start to increase again until I reach my peak speed. Same thing happens going down. Once I get below my deadband for pump village, I'm going to start to decrease by whatever amount I have in this box until I get to low speed. When I get to low speed, I'm going to remain there for whatever I have in this box. And after that time period, if I'm still below the deadband, then I'm going to go down to my slow speed. Then I'll remain there for whatever I have programmed into this box. So If after this time frame expires, I'm still below the dead band, then I'm going to look here to see if my slow speed shutdown is on or off. If it's on, then I'm going to give it a downtime. If it's off, I'm just going to continue to run at my slow speed.
Got it. Okay.
And
So
if
the peak and the slow are basically your max and your min, and then the high and the low are kind of stopping points when you're going one direction or the other too.
yeah, so it's more or less a pause. I mean,
Yeah.
I've been asked, what benefit does that give you? I can't answer that. I don't know. At Lufkin, we just use a peak and a low.
Yeah.
And you could do the same thing here. You could put your high and your peak at the same value and your low and your slow at the same value. You got the same thing.
And then, so if you're at your peak and you have good fillage and it's staying there, and then your fillage drops, it just starts using the speed decrease every stroke until it catches it, right?
Yeah. Well, until you get, so you're at your peak and you get below your dead band, it's going to start decreasing until it gets to the high. It's going to stop there for 2 minutes. If it's still below, then it goes down to the low for 2 minutes. And if it's still below, then it goes down to the slow.
Okay.
It's more, it gives you 4 stages instead of just bouncing from top to bottom.
Got it. Okay. Makes sense. I appreciate that.
You can adjust the duration too. You can make it 0 or you can make it 5 minutes or, whatever you want. This is more or less, you're customizing your or you're optimizing your well here. You're trying to match whatever's going on downhole. You could have a well that when you slow down, it fills up right away. You get a fluid level right away. So you might want to speed up a lot quicker to capture that fluid. You might have one that takes a long time to build up a fluid level and get a full pump, and you may want to remain slow for a long time. But you're trying to match what's going on downhole. So when you look at these numbers here, there's no good set of numbers I can tell you to set them to. It's the performance of your well that determine those numbers. That makes sense?
Just to be clear on the speed decrease, that during that pause, it's not going to continue to decrease based on fillage during that pause, right? It's going to,
right.
Okay.
Right. It's going to wait to see. We could use the word, we're going to let it stabilize for 2 minutes and see what it's going to do.
Right.
They will make another decision after that. In the firmware you guys have out there, you probably don't have the current time in each one of these states. We've added that in this one, I believe. But it will at least tell you, when you're sitting there, if you're looking at it, say, okay, well, I'm at high speed now. It's supposed to be, when you're sitting there watching it, 2 minutes is a long damn time. But at least you can see it counting down. You know how much time you got left before it's supposed to do something.
And there's no way to just do that based on strokes, right? Because like you said, if you're pumping 5 strokes a minute, you may have 10. I'm talking about the changing the duration to strokes, because if and I get you could change the time, I guess, but if you're pumping at 4 strokes a minute, you may get 8 strokes of fluid pound before it even begins to slow.
Well, that's a good idea. We're always looking for ideas from you guys out in the field. Maybe that's something we should consider. I'll bring that up in our next feedback thing, that we have people that are interested, instead of a duration, they're looking at strokes. That's how the speed units. Before we were just hertz, because somebody brought it up. They want to see SPM, so we made the calculation to change it to SPM. Same would apply here. You want strokes rather than duration. And really, that's all we're doing here on this shutdown time. That's duration. This shutdown fillage is strokes. So it's the same principle.
Right.
I'll bring it up.
Yeah, and another thing I could see there is that it would be continuing to find the optimum deal. You wouldn't have to be looking at the duration and trying to figure it yourself, right? So depending on your speed,
yeah,
it may switch it real quick, or it may, allow it to speed back up. So just something to consider.
Yeah, I think that's a good idea. We're always looking for stuff like that. I will definitely bring that one up. Any other questions on this screen then? I mean, it's
No, that was helpful.
okay.
At least.
All right, so let's move on to history now. So our first one is our card history. So the way this works, we save about 3,000 of them in the controller. So you can go back for quite a while to look up some historical information on, was my card, did my card look like this, a month ago or something. So the way this works is we have something called timed. Timed means it goes in while it's running and grabs 5 cards every hour on the hour and stores them. So every hour on the hour, you're going to grab 5 cards and put it in here. Now, if there's a special set of cards while you're looking at it that you want to place in here, that's called reference. That's when I saved it on our real time. I clicked reference and it put that in there. Every time there's a status change, like a start card or a fault card, it'll save the cards for those. Or if it goes into idle, so that's another status change. So each one of these, it'll go in and save 5 cards. And any of those can be exported to a file. I use that a lot when I'm making comparisons. Over time, I'll export these and then I'll put them on an Excel spreadsheet and graph them out and then overlay them on Excel to see what the differences were, how much has changed over time.
Jay, do y'all have any, do y'all currently have the ability to, I know that Xbox is doing it, a lot of different things are doing it, but do you have any way, or are y'all considering any way to have autonomous control based off the cards or the loads?
Well, let's say all of that's on the drawing board. I don't want
Okay.
to give away too much, but there's it's always been there was a time we were going to try to shove XDiag into this thing, but it took up too much memory. So now we're kind of looking at another platform that has a whole lot more memory, and that may come back to life again.
Okay, yeah, and no big deal. I was just curious.
I'm not really a guy to talk to about it. I'm more the VFD guy. Our product line manager could probably give you some ideas where what our roadmap looks like. But I guess the general answer to your question would be, yeah, we're looking at stuff like that.
Okay, just curious. Thanks.
Okay, so events. And again, this is about 3,000 entries. So how far you can go back depends on how many entries you can look at. But it records everything that happens anytime someone changes a configuration, any fault, any start, stop, just anything that goes on is recorded. I can click on that one and I can know, okay, I can see by what happened here, this was me changing from SPM to Hertz. So it records everything that happened to that during that event. This one, see, so there, config, okay, so, this was me changing that digital input. I've got some information on the ESD. But I mean, again, there's so much information here. I mean, it has just been invaluable to me anyway for going back and doing troubleshooting or looking for some kind of trend. Again, every bit of information here can be exported to an Excel file as well. Okay, other trends can be done within the controller itself. So you can go and set up whatever information you want to trend. There's a trend display that you can go through and set it. You know, or at least the ones you want to pick to trend. All right, so right now I've got fluid load and cycles. So I'm trending out fluid load there, cycles, and runtime. So I can also change the time span that I want to look at. There's an internal data logger that I can set up to gather data on any of these set points or parameters, and I can set how often I want to get the information. So I'm data logging it. There's also something called direct CVS data logging that you set this up so you can go through and do the data logging, and if a fault happens, it'll email the log out to whoever's on that on this thread. So you can put your email address in there. When it occurs, you get the log. Or at any point in time, you can export the information. But it's fully configurable. Anything that's got a tag on it can be configured into your display. You can have different time spans for each one. You can data log all of them. You can export them. It can be automatically exported or you can manually export it. Now you probably have a lot of this information already, that capability in Xbox, but it's also built into the controller. There's one called Operation. Sorry?
Hey, Jay. Hey,
Yeah.
I was just gonna, we've got another meeting that we gotta get onto at 10:30. So
Okay.
we're probably gonna have to cut off, but I do wanna thank you very much for your time, and I like this. And we probably need to set something up to go over some more of this, because I'm really liking what I'm seeing, and, you know, being able to see how you're explaining this to us, you know, on your screen. So, you know, if we can definitely set something else up to either pick up where we left off, or if anybody that's on the call has any questions, you know, or other things they'd like to see, maybe we could set something else up again.
Anytime anybody has questions, they can call me directly. We can go.
Okay.
I mean, I'm always around. I always try to answer my phone. Of course, you know, there's always meetings and, you know, stuff like that. Sometimes I can't, but if you leave a message, I promise you, I will always call you back. I will never ignore you.
Okay. Would you mind, hey, Rob, or you or Robbie, would you mind sharing your numbers with us that are on this meeting, and that way we can get in touch with y'all?
Yes, sir. Of course.
Okay.
And Jay, we can keep going. I have it recording, so I can share the rest if you want to keep going through the tabs.
Okay. If you guys got to drop off, then I mean, there's nothing. There's just 3 tabs left, and we're done anyway.
Okay.
I mean, it's just the trending stuff. You know, you've got an operation, you got some production where it looks at oil, water, and gas, and on-off cycles. That was basically all that's left.
Okay. Did anybody that's on, do you guys have any other questions or anything for Jay that you may have for him at this time?
Good.
Okay. All right. Well, I'm going to go ahead and jump off. But Jay and Robbie, like I said, thank you guys very much. I appreciate it, and very good info. And would definitely like to set something else up, and maybe get some more operators involved, so that they can see some of this, because, you know, we're starting to get more and more out here as we have Weatherfords and some of these Lufkins going out, and especially with availability of VFDs and stuff. So definitely be good training.
I would just encourage you guys to get that SMARTEN launcher so you can keep your firmware up to date. I mean, I can come out there and train you guys on it. I mean, it's an easy process, and we're always adding and fixing things, you know, constantly, kind of like Microsoft, I guess. But it's the features we keep adding over time that really would be beneficial.
Yeah, I'll get that updated launcher from you, Jay, and I'll share it with them, so they can start utilizing that as well.
Okay. All right.
Cool. Well, thank you guys again. Appreciate it.
You bet.
No
Thank
problem.
y'all.
Thank you.
Jay, I appreciate your help. And he's gone.